My name is Ilona Riipinen. I'm a professor at Stockholm University, and I would really like to welcome all to this exciting event that we are hosting. It's the project that I coordinate together with Professor Annika Ekman, who is also here in the room, called FORCeS, that is organizing this event, where the topic is air quality and climate policies moving forward after COVID-19 pandemic. And first, just briefly about the FORCeS project. We are a Horizon 2020 project working specifically on the role of aerosols and clouds in the climate system. And kind of the scope of this workshop is to stimulate discussion and also aid us within our project in drafting the next policy brief. So one of the products of this project are policy briefs. And for this year's brief, we have chosen the topic of the recovery plans, especially the recovery plans after the pandemic and their implications for air quality and climate. And we have a really exciting program today. We will first have the presentation of the draft brief where we are looking for input, and this will be done by Professor Erik Källström from SMHI. And then after the presentation, we will have a panel discussion moderated by Hanna Nikkanen, who is a really esteemed journalist with years of experience on investigative journalism and especially environmental questions. And from this discussion, we look forward to getting a lot of interesting inputs for also then finalizing the brief, which will be published and or publicly openly available for everyone. And then after the panel finishes discussing, we will have the Q&A session where everyone in the audience is welcome to pose questions. And this will be moderated in that way that you should post a question through the Q&A icon that you see in your Zoom or should see. And then Hanna will moderate the discussion in the way that she will give you an opportunity to ask your question from the panelists that you would like to direct it to. And then finally, just as a reminder for all of you, we are also recording this event, so that first of all we can watch it later ourselves when we draft the brief, but also to be able to share it for those who maybe cannot join in person today. So this is just a kind of a reminder. Hanna, did I forget something important, or should we get going?
That was perfect, and I think we should get going.
Excellent. So let's get started from the presentation from Erik, who is also our leader for the communications and outreach activities within FORCeS. Welcome, Erik.
Thank you very much, Ilona. And I would also first like to welcome everyone to this webinar. It's very nice to have so many people here. And I will, as Ilona said, present this draft brief that we have produced so far, and also looking forward to the discussions and how we can then think about how to complete this one later. So the brief is about air quality and climate policies and the way of moving forward after the pandemic. And the work has been done here in the FORCeS project by the people listed here. And it's mainly Helena Martins who have written the first draft and worked on this, together with myself and Hans Christian Hansson here from the Stockholm University. There has also been a lot of contributions from the FORCeS participants, and I would really like to highlight that here. And also, and Ilona, you didn't say that, the whole workshop is actually also co-organized with another project, a Swedish project called CoClim19, and we have also had some help there from on the climate modeling side. So that we will come back to that in a minute or two as well. So I will just go on then and quickly present what we have started with in this brief so far. And of course, we start out with just looking at the big picture here, what really happened last year then when everything was shut down. There were very strong impacts, of course, and this picture here is from a review paper from this year, really going through quite a lot of literature. Actually, they are reviewing more than 200 papers on the pandemic and its impact on air quality and climate. So there have already been a lot of research done in the subject. And as you can see here from the figure to the left, I guess many of you are quite aware about air quality and climate things, of course, but it's of course a very intricate and complex system here involving human activity within cities and in urban areas, and there are atmospheric chemistry and impacts on chemistry, and then that also have a strong relation then to climate and climate change. So there is a lot of emissions of primary air pollutants, and these are listed here to the left. It's apart from CO2, carbon dioxide, there are also a lot of other greenhouse gases and different pollutants, and they can then be transferred into the atmosphere into secondary pollutants, and that includes also aerosol particles, for instance. And all of this is both dependent on the meteorological situation, but then of course also on the emissions, and so it's a very intricate problem. In the time of the pandemic, there were big shutdowns basically all over the world, and that had a strong impact, of course. Many of these emissions were reduced, and they were heavily reduced in the last spring, then starting in March last year. And the main or the largest reductions in many of these compounds were found later in spring that year, in March and April. And you can see here to the right in the figure the concentration changes here for some of the pollutants here, like nitrous oxides, for instance, and also particulate matter that also decreased on a global scale here. Then there were some increases also, of course, in ozone, which then reacts on the rest of the chemical soup in the atmosphere, and that is one of these secondary pollutants that in some areas were actually increased. I should also say here that the authors, they really describe this as a very big, like an extreme real world experiment in which you could look at what happens when certain sectors are more or less cut off within their emissions. So this is what we saw there in terms of air quality, a lot of reductions and differences in some of these pollutants. And then if we go on here and look at carbon dioxide, of course, there was also the large reductions in emissions led to very large reductions also in CO2. And here you can see to the right emission changes per sector. And you can see there, for instance, on the top right, that surface transport was heavily affected by this, and even more in relative terms for aviation. And as these are different in their size, the surface transport was actually the biggest drop. Altogether, the CO2 emissions are estimated to have gone down by about 17% in the month of April. So that was a really dramatic decrease for that month. Then later on, it was increasing or recovering again over the year. So this is what, if we try to summarize what happened with CO2 in the last year, and here you can see to the left, this is a very new figure actually from the Global Carbon Project that was published actually last week. So you can see here now the new number for 2020, and it shows a drop with 5.4% compared to the year before. And this is a little bit lower compared to what was assessed before in the IPCC report, where 7% was given. But still, it is a substantial drop, and it's the biggest relative drop that you can see in this historical time series. At the same time, you can also mark that 2020 is actually still among the top 10 years in terms of the emissions. So there were very large emissions last year, despite this decrease. And this is, of course, what results the still ongoing increase in CO2 concentrations, as the emissions are still very high, emissions are increasing. And there is, you can't see in any of the concentrations that there were these large drops last year. So this is what the rightmost graph here show the record from Mauna Loa, indicating that you see still an increase, which is expected, as said. So that's about the emissions, and then the question is how this could then have impacted the climate and also air quality. And starting on climate here, so this is a graph to the left from the IPCC AR6 report. There was a special box written on COVID and on the COVID pandemic and its impact on climate. And they cite one paper here, and these are the numbers given here in the box to the right, where FORCeS et al. Look at differences in what really happened to the forcing in that year. So what is claimed there is that the avoided CO2 emissions, they were lower last year. That had a slight reduction then in the radiative forcing. These numbers here, watts per square meter, are radiative forcing, and you can compare everything with what is the base level of anthropogenic forcing in the year of 2019. That's given in the box up there on top. So that's almost, it's above 2.7 watts per square meter now. So there were reductions, but compared to that number, they are of course relatively small still. There were also other reductions, other things happened. Tropospheric ozone in total changed, as I indicated before, and that has some impact. There were also less aerosol particles, which has a warming effect, since many of these aerosol particles are cooling the climate. And this is what's seen basically in the map to the left, which shows something called the the optical depth of the atmosphere, which indicates then how thick it is, so to speak, with these aerosols that disperse the solar radiation. And the green numbers here, or the green colors here, indicate that was really changing. So they're decreasing this aerosol depth. More sunlight coming into the surface, increasing the incident solar energy. So in the FORCeS et al. Paper, they summarize things here that in spring the impact was 0.05 watts per square meter positive. So that means actually a warming signal, and this is the warming signal of the reduction in these cooling aerosols. So that this is what we really saw. So there was no cooling or anything last year. It was rather a warming. And at the end of the year, when many of these aerosols have been washed out, etc., and are removed, then this impact is smaller then, of course. So these are in terms of forcing. There are no detectable changes in either temperature or precipitation from observations from last year. You can't really measure this. The impacts are too small. In climate models, you can see some impacts if you run them and test them with or without these changes, but these changes are so small. So compared to any kind of interannual variability in meteorology, etc., and weather, and you can't really see, and you can't expect to find any of these changes in the observations. So that was about the climate impacts. And then we also talked about the air quality impacts a little bit. So now I will turn into the future instead, and the recovery time and what will now happen. So how will now air quality and climate be affected by after the pandemic? What's happening with the recovery plans? And here is a graph showing now some different scenarios, as we don't know exactly what will happen in the future. These are some ideas about what could happen. And in this graph to the left, there are basically 4 different scenarios. This blue line here, it's the baseline scenario. It follows the previous NDCs, the National Determined Contributions, until 2030. And then it assumes no significant strengthening in climate action. So there you can see here a slight increase over time in this, according to this scenario. Then there are a couple of other ones. First, they all start with this kind of blip here where there is a strong reduction, and then some of them show this fossil fuel recovery, a strong increase again. This is the yellow line here. And it even exceeds the baseline, and it stays above that, and it even gets stronger. So at 2030, we're about 10% above the baseline, and that difference is continued then over time. Then there are 2 so-called green recovery scenarios instead. There is one moderate one here and a strong green reduction scenario here. And they both point to reductions in greenhouse gases, and quite strong reductions over time. So there are large differences here at the end of this series, if you look to the right in the figure. So what kind of impact could this have? So these are now some integrations from something called the COVID MIP, so these are climate models that have been running these scenarios for the future, and here you can see how they differ over time, and actually they don't differ that much in the beginning, but after some decades here there starts to really diverge here. So the baseline and the fossil fuel intense, they really continuous increase here in global mean temperature, while the other ones, they are falling off like this. And you can see that also in impacts on the regional scale here. So here are differences between these different scenarios. So this is the reference simulation. This is just one of the models indicating these are temperature, maximum temperatures in a 10-year period. And then there are differences here in the other scenarios compared to that one. So if you look at the strong green one, the maximum temperatures don't increase as much. There are a lot of blue colors in this graph here. You can see other things like in the Arctic, you can see strong decreases in sea ice that has already been started, of course, as you know from the observations. The maximum ice cover is much smaller today compared to in the beginning of the 1980s. And what these models now show is continued decrease along these lines. But then, of course, again, different differences emerge here around 2040 or so. And then the strong decrease in the baseline scenario is kind of leveled off here a bit in these green recovery scenarios. We have another just a test of tried to look at some impacts, and here we have looked at tick-borne encephalitis. This is a virus that can harm your brain basically. So when you get bitten by this small insect here, you can get this disease, and it's most common in Central and Northern Europe, as you see here. This is the number of incidences. And then you can see there is also a trend here, some kind of increase, and that it has been speculated that that has to do with climate, or at least partly. There could also be other factors, but less cold and very cold situations in winter are beneficial for these small creatures, and that's why they might increase over time. So this is just one other example showing here how then the number of very cold days when the temperature, the minimum temperature is below 10 degrees, how that changes in time, and there is a less decrease in the number of such cold days in these green recovery scenarios. So this is then could be a potential positive impact of reducing the emissions of all of these things. Finally, I will go into also the air quality impacts here, and this is just one graph that I recently got from IASA, from one of our colleagues in the FORCeS project there. And here to the right again, you can see two scenarios. The blue one is the baseline, and the brownish or orange line here is a net zero, where there are strong emission reductions in all of these scenarios. And I would just quickly remark up here to the upper right, there is also a dashed line, and these are now with the very, very new announced pledges. So these are fresh from just a couple of days back. So we don't have these numbers for the graph here to the left, and that should be, you should be reminded about that. So the difference between these lines are not as big as shown here. But what this one shows is the number of people exposed to particulate matter, and that is in today's situation, and then at 2 time points in the future with the existing legislation, the baseline scenarios, or with the net zero emissions. And you can see that the gray fraction, which is low condition or low concentrations of particulate matter, that increases if you go to the net zero emission, of course. So with lower emissions of air pollutants, obviously you get lower particulate matter concentrations. So, and these impacts here are really very, very big. So there are very many people and large fractions of the population that has an improved situation with the low emission scenarios here compared to in the other, both at short term and even more so at long term. And that is basically what I had. So now we will get back here to the lessons, what we can learn about this. And this is again the same graph as shown before, with the only addition here of this red point, which is now the projection for 2021. So we can now say that we are here today. This blip, as I called it before, it has more or less gone now. So we are more or less back on track again. So the question is, of course, what will happen now in the future? And this is what we are going to discuss here now. So now I will actually finish here and leave it to Hannah to take it up for the panel discussion. Thank you.
Thank you, Eric. And on my part, I want to also welcome everyone in the audience to the workshop, and a special welcome from me to our 5 distinguished panelists, whom I will be introducing in just a minute. And briefly about the agenda, as Ilona said, so we will have this panel discussion now, and that will be followed by a general discussion. And if anyone has just recently joined, so I'll just tell you that you can post questions in the question and the Q&A area on Zoom. And I will be keeping an eye on your questions. So then when there is time for general discussion after the panel, I'll be picking up questions from the Q&A. I may ask you to turn on your mic and actually pose the question, or if we're short on time, I might read those questions out loud. We'll see how that goes, like which works better. But now it's time to start our panel. And our first panelist is Professor John Hassler from the Institute for International Economic Studies at Stockholm University. He's an expert on the links between climate change and economy. And I wanted to start kind of introduce you to our audience by asking you one question. When the pandemic first broke out last year, what were your first expectations for the immediate economic consequences of COVID?
Well, I was pretty worried. So in the beginning, we saw that a number of processes started that actually I think could have taken us into a depression, a global depression of the size equal to what we saw in the 30s. And in particular, we saw things happening on the financial markets that could have triggered these feedback mechanisms that really, amplifies the consequences and prolongs them of some shock. It was a massive shock to the economy, but had we also seen a complete crash of asset prices, a banking crisis, a housing crash, then clearly we would have been in a much worse situation than actually we turned out to come into. And the main reason, I think, for why we didn't see that was very swift and massive actions from the central banks. They basically went in and said that whoever is worried about their assets, come to us and you'll get cash instead. Of course, nowadays it's not cash; it's credits on an account in the central bank. But due to a long history of inflation targeting, people were not worried about risks associated with inflation, and so then they took that, and that calmed down the markets. And then when it a bit later also turned out that the early forecasts of when a vaccine were to come were changed, so that instead of having to wait many years for it, it became in the summer clear that already in 2021 we would have vaccines. Then things turned around, and so it became not at all as bad as I expected it could have been, and not only me.
Thank you. And then our second panelist is Dr. Franz Imler, and he's head of sector at CINEA, the Climate and Infrastructure and Environment Executive Agency of the European Commission, and he's implementing climate research activities in Brussels. So welcome, Franz. And initially in public discourse, when we're talking about last year, there was an expectation that at least now we could see finally human-caused CO2 emissions drop, and that would potentially slow down global warming due to lockdowns. So there was this hope that the pandemic might have a silver lining. Was this the case?
Thanks for the question, and thanks for inviting me, and welcome everybody. Maybe quickly, if I may add, so I'm working at the European Commission, or at the executive agency, and we run the the Horizon Europe program on climate issues. So I cannot speak on behalf of the Commission, of course, but I will use the opportunity to advertise our program and our projects. One of which is FORCeS that we are running, but there are many others, about 100 actually, that we have running in this domain. Another one is, for example, constraint, and I've seen, I think, one of the slides that were shown earlier, based on their studies that showed that the CO2 emissions have been reduced dramatically. We have seen that. But okay, globally it was 17% less in 1 month, and then it recovered quickly. And of course, the CO2 concentrations in the atmosphere has not decreased because of that. On the contrary, it's still increasing. And we even see that because of the aerosol, there was rather warming than cooling. So of course, what comes from the pandemic is just a short dip in the worst case scenario, and then we recover quickly back to previous emission levels or even higher, as was also shown in this one graph. So so what is important is what is, you know, is there a policy change happening? And I think the European Union, which was also in a very interesting situation in the beginning of the pandemic, when you saw each national government was doing something else. It was quite a chaotic picture, but I think it was a good moment also for Europe, because after a while, the governments understood we have to address this crisis jointly, and we have to work together on various aspects, on the vaccine, for example, and other aspects, but also on a recovery plan. And I think the EU recovery plan that was brought up is quite a unique chance to start out of this crisis, of this pandemic crisis, with a change in introducing a change in the economy towards more low carbon support. It's not clear how we will end with that, but I think a very good start is done.
Thank you. And next up, we have Professor Astrid Kinle-Schar, and she's one of the principal investigators in FORCeS, also the director of the Institute for Energy and Climate at the Jülich Research Center, and also an author of the chapter on short-lived climate forcers in the latest IPCC report. So when the restrictions started coming into effect across Europe in March 2020, did you already know what kind of an atmospheric impact to expect?
Well, no, we did not. And putting all other aspects of the pandemic aside, of course, it was fascinating to see that we have those very strong reductions in traffic. We have sectors that did decrease drastically in emissions. And so my institute, for instance, got ready to start measurements on the atmospheric composition. We managed to have a Zeppelin mission to explore what the emission reductions do in the Rhineland area where we live. And I also coordinated both the review article that was cited earlier and also the chapter or the box in the IPCC report covering what happened for the pandemic in terms of air quality and climate implications. And of course, it became obvious very quickly that because of their short lifetime, the short-lived climate forcers do respond relatively quickly on emission changes. And that has the implications on air quality that you could in principle expect. But of course, atmospheric chemistry is a complex thing. There is a lot of non-linearities involved. So having this real-world example is really going to be a treasure box of data for the next years and decades to come, to see and make use of data sets and also benchmark our models with and see where do the models perform correctly, where do we have uncertainties that we still have to fix in the models. And I think the highlighting element that for the air quality element, we cannot just take measurements and conclude based on the observed concentrations what the emission was, but we have to account for the meteorological condition. We knew that in the community before, but it became more obvious that we need tools that are more ready-made to allow for a quick assessment of what does that mean in terms of emission changes. And that's not so straightforward to really put numbers to.
And I really love the definition of, or like the idea of a treasure box of data for the decades to come, which is kind of what we're also, one of the topics that we're talking about here today is kind of like, what do we do? What do we learn from this data? And then what does that show us on the way forward? And it feels great to be feeling excited about something pandemic related for once. But then our fourth panelist is Dr. Torben König from the Swedish Meteorological and Hydrological Institute. He's an expert on the links between the COVID-19 pandemic and climate. He's leading the FORCeS project on green COVID recovery packages. And now, as has already been mentioned, that there is like the blip may be followed by a jump. We know from earlier crises that a drop in emissions often is followed by and like an even faster growth of in emissions. And is it inevitable that we will see a hike in emissions during the next few years?
What we normally see after such crises, which lead to a decreased demand for energy, is that we see a reduction in the emissions, as you said. But then as soon as economy is recovering and emissions go up, we also see again increase in emissions, and often close to the baseline that we had before. So we come close to emissions that we would expect if we wouldn't have such a crisis. And we see a similar thing now at the moment as well. We had a strong reduction in 2020, but now in 2021, we are almost at the level of 2019. And according to forecast from the IEA, the International Energy Agency, 2022 emissions will continue to rise. So now if we want to reach the Paris Agreement, of course, we need to reduce emissions every year by 6 to 7% now until the year 2030. So this is a bit in contrast. So what is then needed is to drastically reduce emissions as soon as possible so that we don't continue to increase emissions in the future. But I think it's almost inevitable that in the next year, we will see an additional increase in emissions. But hopefully after that, measures can help to reduce emissions.
Okay, so we're kind of aiming, we're already talking about 2023 realistically.
I think so, yes.
Yeah. Okay, and then our fifth and last panelist is Professor Joachim Rochlöv from the Department of Public Health and Clinical Medicine at Umeå University. He's an epidemiologist focusing on global health and global environmental change and infectious disease. And well, your work, as it focuses on this idea that health crises and environmental crises are intertwined, can you kind of give us a short elevator pitch on how these links work, and what is the biggest issue that decision makers now need to understand about the connection between climate and biodiversity and human health in the future?
I'll make a try. Yeah, health and climate and environment is interlinked by many different things and in many different ways. And the most important ways to link it is behavior and lifestyle, which is actually also related to air pollution, emissions and CO2 emissions. So that's one way to look at also health wins or health impacts in relation to the climate and also the pandemic situation. Another way is basically the warming and environmental and global climate change, where we could look at health impacts in terms of impacts from direct exposures like heat, for example. And we know that heat exposure and heat impacts is going up and has been going up for a long time. I think that the latest study I've looked at attributed about 30-40% increase of heat mortality globally due to the warming observed up to today. And then there is impacts on pollens, and there is impacts on which is related to biodiversity as well, and there is impacts on infectious diseases, and the impacts are and food and nutrition, of course, as well. The impacts are spread over so many different pathways. It's almost impossible to go through all of them in one sort of pitch. But if you look at some of the infectious diseases that we see in Sweden, for example, TB is certainly linked to climate. There is, as was mentioned before, the life cycle of the vector and the interaction with reservoir hosts like deer, etc., is linked to climate. And one can see, depending on the season, the start of the season, one can see that climate variability is definitely important in determining the size of the outbreak and also the geographical zones of transmission. And that's the same for a lot of infectious diseases. You can look at West Nile, for example, and other diseases which are to some extent becoming more important even for Europe. Looking at pandemic risk factors, I think one would need to go back to what we were discussing. First of all, the behavior components. Thinking about pandemic links to climate environment and so on. I think it's more around the lifestyle and meat consumption, for example, and how we interact with wildlife and exploit forest areas, causing animals to having to change their behaviors and adapt to new situations, which can lead to spillover. There's a lot of knowledge gaps, though, in that domain, I would say, but it's quite clear that there's a strong linkage. Also, I think there's, in thinking about that, there's also knowledge gaps, but there's also linkages between meat consumption, which causes CO2 emissions for at least, more or less, depending on how it's produced. And which is also linked to spillover, of course, which is also linked to AMR to some extent, like antimicrobial resistance. So there is a lot of linkages between health, and health is very fundamentally important for everyone, which we also can see from the pandemic. So there is a lot of benefits and opportunities to actually improve health and reduce health impacts, and thinking about those things as one system instead of separating them out. That's my, I don't know, short or long pitch.
Okay, thank you. That was wonderful. And this was now I've presented all of our panelists, and now we can move on to talking about we just heard Erik's presentation on the policy brief. And kind of expanding on that, I wanted to ask you, Astrid, what is happening with air quality now that society is reopened? What's the latest data in your treasure box?
Well, of course, if you go back having traffic emissions, then all the air quality related issues that go along with those emissions reoccur. I would also like to emphasize, I mean, those emission changes that we observed, they were never targeted to do either something for air quality or something good for climate. They only happened as a result of the stay-at-home orders. So it was a total by chance thing. There was no dedication, no strategy that would improve air quality or climate implications. And so we should not feel frustrated about this large drop in emissions not doing something good for climate, because it was never thought out to do that. I think what we can also state is that because there is this co-emission of the short-lived climate forcers and the CO2, of course, on the short term, we do not see a reduction in temperatures or the warming caused by the CO2. But one has to emphasize, and that is also something that we emphasize in our chapter in the latest IPCC report, that emission reductions and their climate implications will in the long term be dominated by the CO2 effects. Because if you take out any aerosol or aerosol precursors, you do that once, the aerosol vanishes, so the warming effect is there instantaneously, more or less, but it's only there once. Whereas for the CO2, if you take well, you don't take it out, you just don't emit it, then you will avoid a warming effect for a long term. And that is a difference to emphasize when looking into the implications.
Thank you. Then Torben, now that we've seen these different recovery scenarios, we had the baseline scenario, and then we had 3 different scenarios on top of that. Can you tell us more about those? What would you see as the main differences in terms of like what is causing different climate impacts in these different recovery scenarios? What do we know about them?
Yeah, the main difference, as Erik already showed, is of course that if we follow a strong green recovery scenario, we really have a chance to stay below a warming of 2 degrees, the limit, or maybe even close to 1.5 degrees. And the main reason is that the CO2 content or the CO2 emissions in this scenario are strongly reduced. They reach 0 in the strong green emission scenario in year 2050, which then also means that we can stabilize or maybe even go a bit back from a warming level of 1.5 to 2 degrees. While if we follow more the baseline scenario, we will continue warming even after 2050, because we still emit CO2 and other greenhouse gases into the atmosphere. So that's also important to see that the world is not ending 2050, but we are of course continuing after that. If we look maybe a bit more at the Swedish level, we saw that the largest impact is mostly on minimum daily temperatures. So we see a stronger reduction of the warming in the strong green scenario until 2050 in the nights than at the days. So, and this has of course an impact on number of frost days, of 0 crossings, and also of these tick temperature, minimum temperatures, cold temperatures that are important for the ticks and TBE, for example. So I think that is some points to mention between the different scenarios. And of course, what is also interesting and which we have not fully understood, I think, is that in this fossil fuel scenario where we go over the emission scenario, we have emissions which are always a bit higher than in the baseline scenario, but still the temperature, global temperature effect is not distinguishable from the baseline scenario. And I think that's something to look a bit more into it, why that is. I mean, the difference is not as large as between the baseline and the strong green scenario. That is certainly one explanation, but still it's a bit surprising that there is hardly any difference between these
two. I was actually going to ask you about that, because that caught my eye as well. Last year, Bloomberg Green estimated that in the COVID stimulus, the stimulus packages that the 50 largest economies announced last year, that green measures accounted for less than 0.2% in those packages. So that was the situation last year. They're talking about kind of the beginning of the pandemic, the immediate economic response. But I wanted to ask you, and this is kind of to all of the panelists, are current recovery plans as bleak, or have they become greener after last year?
I think this is probably a good question also for John. To my knowledge, they are still not very green, the recovery packages. So we are not really following, or the plans are not really following the strong green or even the moderate green scenario, according to my knowledge. And if compared to the scenarios, what is happening this year and probably also next year, we are already substantially above the scenario, which should lead to a strong green scenario.
How about you, John? How would you say? Are we still are we still far from the two different green recovery paths?
Well, I think that actually the recovery plans are a sideshow, and it's easiest to understand that if you think about EU. In EU, the Commission has proposed that we should phase out emission rights at twice as high speed as before in the emission trading system, and that's gonna imply that in these areas that covers around 40% of emissions in EU, we're not going to have any emissions at 2050, and emission rights are not going to be given out after 2040. And that, of course, then means that the industry is there, including, for example, aviation within the countries of the Union. If they have not come up with a way of flying without using fossil fuel by 2040, will have to close, right? This proposal that's going to halve the emissions from the Union in these industries then until 2050. That's very important, right? And in this package, there is also an investment plan. That's not very important. If this system is put in place, we know how much emissions will fall over time. We will know how much accumulated emissions will be generated. And we can calculate the climate impact of those. That's going to be about 0.01 degrees, right? If we don't make the green investment package, maybe it's going to be a little bit more difficult, but we're going to reach the goal anyway. So I think that if we talk about consequences of COVID for whether we kind of are going to go for a quicker transition to green, we shouldn't focus on the kind of how the recovery packages are constructed. We should look at are we on the track? Is how large is the chance that we will actually put this system in place in the EU, and how large is the chances that other countries will do that? That's the important thing, and I don't think that the COVID in itself really provided any golden opportunity for making it more plausible that we introduce these kinds of policies that we know will work. It's true that lots of money was spent by governments, but these were transactions, and they were transfers to individuals and to firms. They were not investments. It's true that for example, the Biden investment plan, that is real money that's going to be spent on investment, and there is if that helps in making people in the US accept an emission trading system or a tax on emissions, then it might work, but it's not the investment in itself.
How do you feel about that, Torben? Is green recovery, is that a sideshow? Is the actual play being played somewhere else?
I'm not an expert on emission taxes and so on, but for me, I think it's a combination of all things, because I think it's probably naive to think that if we would have introduced taxes on emissions in a few years, even if we would make that globally, which we are not doing at all at the moment, we have exceptions for most of the heavy industry in terms of emission taxes. So, but if we think that at the end in 2040, industry part sections have to close down because they cannot operate anymore, that this politically would really happening. So I'm a bit skeptical that this is really the case, that at some time we have used all the carbon budget, emission prices are going up into the air, and everything which cannot pay it has to close down. even if there's not enough energy for industries and even for people for heating and so on. So I think then priorities will put away from the climate. So I think both is needed. We need investments as many as possible. We need to try to reduce, to increase energy demand as much as possible, but at the same time follow the way that John is suggesting.
But I agree that, of course, we are not going to close down governments and take away all economic policies. And some of the policies that governments are doing is helping industry, you know, and maybe the airline industry will say that, well, we need engineers that can help us with electrifying planes, and we can't do that ourselves. We need the government to help us with that. Of course, I mean, and the government is, of course, not going to sit idle for the coming 40 years. But without the pricing system, preferably by an emission trading system, it's not going to happen. And I'm fairly sure that if we put that in place, all these companies are going to come up with ideas of flying without fossil fuel and making cement and steel without fossil fuel too. So I'm not very worried. And most of these investments are going to make this possible. It's not going to be paid by the taxpayers. It's going to be paid by investors.
You said that you don't see COVID as having given like a golden opportunity to make that happen. But do you think COVID might actually set back those plans?
It could have. So I think it's very clear that if people come into large economic troubles and become feared about the future, that's not a very politically productive climate for introducing these kinds of policies. So and one way of saying it is that had we kind of come into a situation with very high and unemployment in Europe, then it would have been much more difficult for Polish coal miners to find a new job. So the fact that we recovered fast is very good for the climate. That I'm sure about.
Franz, what do you think?
Well, I think it's clear that COVID cannot replace any climate policy. Then climate policies have been in place before and have been accelerated independently of COVID. And indeed, there's a risk that a lot of people think now first we need to restart the economy and have a fossil fuel-based restart, and this risk is certainly there also globally. On the other hand, I think there's a chance that some of the effects of COVID can accelerate a transition to a more low-carbon economy, at least in Europe or in some places. The EU recovery package has a strong element in that. 30% of the spending needs to be climate-related of the Next Generation EU package. We see a lot in member states now investments into a more low-carbon economy, for example, electric cars, electric recharging structures, etc. I cannot assess, it's not my area of expertise, whether this is enough, but I think there's a chance that COVID may accelerate some of the transition that would be needed or will be needed for effective climate policy, also in other areas. I mean, we talk now remotely. I did not travel to Stockholm. These are things that it's a pity, actually. I like Stockholm a lot and it would be nice to see you in person. On the other hand, some of these features will stay and can also help contributing to a less carbon intense way of working. We see this also in the Commission. We will do a lot more in remote, in teleworking and so on. So there are things that can help at least a bit, but of course it needs to be supported in this transition by a strong climate policy. That's important, and not by a COVID recovery policy. These are two different things.
And that's actually one thing I wanted to ask you about, because that's now that people are returning to work at the office and there's more travel. So there's a lot of talk about that. How, like, if work from home and online meetings, online conferencing, if these changes are to some level here to stay, how large will that impact on emissions realistically be? And this is a question to all of your panelists. This is also, I mean, like Joachim said, these are also like behavior and lifestyle changes that may have unforeseen, or like may have a larger impact, or they might be again a part of the sideshow. What do you think?
You want me to? First, I cannot assess this. I think it can help a bit, but certainly not a lot. What isn't really important is that people change the way they live. So these behavioral changes and lifestyle changes, this is very difficult. We see still in Germany, it's in the press, an increase of people buying big cars and so on. It's not going to be less. And there's still a lot of work to be done. But I think this link with health is quite an interesting one, because people are concerned about the health and air pollution and also diseases, of course. And this could be an important aspect, that really people change behavior, and that's what we need. So that's why I invest also in this research, in this project, and other projects like Exhaustion, that looks into these links between climate and health. And I think people are concerned about health and communicating as much as possible that healthier lifestyle is also a more climate-friendly lifestyle. Also the diet, for example, less meat, less air pollution would be important. I think that can make also strong contribution for a more climate-friendly economy.
John, what do you think? How much of a contribution do you see in everyday changes, working from home?
Well, you know, if you consider again the proposals from the Commission, which one of the proposals is to have an emission trading system for transportation, where transportation is included. Then, of course, emissions within that system is going to depend on how many emission allowances are going to be allowed. And that's going to be 11 gigatons of CO2 emissions until, you know, the system is phased out. So then, you know, that's what the emissions are going to be. But I agree with Torben and others that, you know, of course, people have to accept that. And perhaps it is the case that COVID has showed us that, you know, the way we organize work and the way we live is more flexible than we expected. So maybe then people are not so worried about introducing a system like that. So in that sense, it could be beneficial. We have shown that also in the short run, the way we organize our lives, it's pretty flexible, but I don't think it's going to be that's not going to be the way how we you know, change our emissions, that we drive much less, for example. That's not going to be, and I think that's important to realize also when we talk about the lessons from COVID, that what we know and what our research has focused on is that you know, in the short run, the economy is not so flexible. It turned out to be more flexible than we thought anyway. But in the short run, you can't really reduce energy consumption without reducing GDP, and you can't really, you know, reduce emissions from traffic without having less travels. That's not true in the longer run. So in the longer run, very different mechanisms are associated with energy use, and in the longer run, it's very clear that energy use is not parallel with GDP. That's going to depend on the price and what alternatives exist. So I think that's very, the way we have reduced emissions during the COVID crisis, that's not the way we're going to reduce emissions in order to get climate neutral by 2050.
Torben, you have a comment.
Yes, coming back to that question as well, I made a very rough calculations with a lot of ifs and assumptions and speculations. But I think the transport sector is creating a bit more than 20% of global emissions, a third of them coming from cars, being down to 7 or 8% or so. Then if 50% of all car journeys are work traveling and 30% of the people working from home, then you would end up with 1.5% of reduction of emissions. Conferences and so on, less flying, maybe the same amount again. So this is not a very big part. But of course, every small part helps, and Yeah, and we saw from the reduction of only, I would say, 5-6% in the last year 2020 of emissions, despite very strict mobility restrictions in many parts of the world, that just reducing mobility is not the only way. It can help a bit, but we really need a transformation of the entire system.
Yeah. So, and I guess this is what we often come down to, that any single change, or like John said, any kind of a change that we could see in the short term during the COVID pandemic, that will not be enough. There's no silver bullet that this one thing is changed and then that's enough.
It's not going to do it at all, I think. I mean, Volkswagen is surely thinking of, that they have a chance of selling cars also after 2030, when they are not allowed to sell any fossil cars. And they invest a lot in that, much more than the recovery plans are giving them.
Joachim, you have a comment, please.
Yeah, I just wanted to add on that, that I think I think that's been pretty clear from what was presented before, that the change is overall not enough large in terms of CO2. I mean, it's small compared to, the global trends. So that's really important. But I still think in psychologically to see that we as populations can actually change our behavior in ways that we didn't think was really possible in the beginning of the pandemic, for example, to work on a distance and not travel in the same way. It's still important, I think, in this transformative pathway that we are actually moving on at the moment to I think we're afraid of changes overall, and making changes, but we can actually maybe better understand that we are capable of making larger changes than we thought maybe, and that it can have positive impacts. And I hope there will be much more studies on, for example, air pollution. There's a number of air pollution studies also attributing health impacts to the reductions that you also described before. And I think there will be many more coming out from studying various impacts of the pandemic restriction, the changes in terms of environment and health impacts as well, which would give us some ideas on what type of potential health wins there are in terms of exposures as well. And if we know that we could have much less impacts on mortality and morbidity from air pollution, for example, do we still choose to live with those exposures, or would we, it would be convincing, I think, to a lot of people to embark on these pathways and transformative changes.
Thank you, Joachim. What do you say, Astrid?
I would like to emphasize that I would personally make a very big distinction between the behavioral changes that were necessary in the pandemic, which were enforced and which also brought along quite a number of stress factors, particularly for families, I think. So from those that may be there when we transition to a carbon neutral economy, because there potentially I'm just keep on driving my car. It's just not going to be powered by fossil fuels. So I think the behavioral changes are going to have a very strong technological element in it, which in a number of terms will not require as much of individual changes as the ones of stay-at-home orders did for the pandemic. I would also think that really emphasizing the health benefits in the context of improved air quality is certainly a strong way forward. And I mean, World Health Organization assesses that air quality is the #1 environmental health risk. It is more important a health risk than poor water quality, for instance. And that's quite logical, because if you don't trust the water quality that is provided to you, you can choose to drink something else. But There is no way you can avoid breathing the poor air quality that you're exposed to in the place you're living. And also all the guideline values that had been there from World Health Organization have been adapted in the new guideline values and are now lower than they had been before. So there's even a stronger need to improve air quality to make sure there is reduced health risks than we thought before.
And what is the main argument, Astrid, for? Because I was thinking about what you said earlier about that atmospheric chemistry is complex. There are necessarily lots of unknowns, especially if we go for if we move to a very different scenario than what we know already. So what are the main benefits to health and well-being of staying on the strong green recovery pathway, or whatever we call that, but doing staying on or moving to a fast emissions reductions track? What are the main health benefits of doing a major change? Sorry for being confusing in my question. I was trying to formulate it as I went.
No, I think it was quite clear. So I mean, the main air pollutants with health risks are particulate matter and ozone. And they are associated with a lot of individual health risks from cardiovascular to all kinds of chronic diseases of the breathing system, up towards being associated with potential higher risks of dementia and other diseases. So avoiding those exposures is certainly the benefit. So if the question was which sectors or which pollutants are probably the most promising ones, the IPCC report emphasized methane as one of the short-lived climate forces which have a strong impact on climate forcing, and at the same time, because the atmospheric chemistry and removal of methane out of the atmosphere leads to ozone formation. So if you avoid or reduce methane emissions, then that ozone formation can be avoided. And so you get both things at the same time. You improve air quality, and you also reduce the warming from a really potent greenhouse gas. For the aerosols, we already discussed that could be seen as conflicting, because if you take out the aerosols, you take out a cooling component. But again, as I said before, in the long term, if you take out the sector that emits the precursors, you also take out the CO2 emissions from that if you defossilize. And that means that the reduced greenhouse gas emission is going to dominate. And so you can still benefit both the air quality and the climate element.
Do you have, Astrid, the data, the treasure box of data that you have now from the COVID era? Is that something that can be used to optimize future climate and air quality policies?
I think we are not quite there yet in terms of having a full enough picture. A lot of the strongest restrictions happened only in springtime. So we do not have full seasonal coverage. And a lot of the measurements that were taken are these, either remote sensing satellite measurements that don't involve people in the field, or routine measurements that are oftentimes not as detailed in terms of which compounds do we measure as we as atmospheric chemists would like them to have. So there's certainly still room for more analysis, and of course we can retreat back to what we used to do in terms of using models to evaluate which emission change is going to have which impact in the air quality in particular.
Okay. Thank you. Joachim, did you have a comment there? You had your hand up for a moment.
Yeah, no, I think I just wanted to comment on behavior changes. Those are difficult, obviously, but I think there's a big wealth of health, both on both sides of the climate environment side, that need to be emphasized and understood and communicated. I think people's literacy about those impacts is too low to actually to get these policies through in an efficient way. I think that's also part. I also think there's a lot of examples where behavior changes has been the main sort of endpoint to public health intervention. It's been working out more or less okay, depending on the situation, but there's definitely successful situations and where there's a combination of policy and information and knowledge and understanding of the risks that could drive a change in behaviors. I wouldn't want to totally under sort of value those.
I wasn't going to imply that, Joachim. I fully agree with that. I mean, stop smoking is going to really serve your health. That's for sure. I was just trying to make clear that stay at home was not a behavioral change that I think does benefit all of the society. And there was a lot of stress involved for families, for instance, who had to do everything in parallel at home and were quite left alone with all the challenges involved. So of course, dietary changes, but also mobility choices will have very strong health benefits, potentially at least if you take the right choices.
Okay, thanks.
To Torben, I wanted to ask you, kind of continuing on this thread of how to use data to optimize future policies regarding climate and regarding air quality. How can climate models, how can modeling help us use existing data to craft the best policies possible?
Yeah, first of all, models can of course use different emission scenarios, different compositions of emissions and land uses to see what is the change in climate as response to these scenarios or changes, and thus of course provide information to the policy, but also to the impact community data, which then can be used to further analyze the impacts and give better qualified information about impacts and costs for society. So data are always important for the models to evaluate the model, to see if the models are doing the right thing, maybe also to start the models and under certain conditions and so on. I think one thing we should not forget is that models are still under development. So we're talking often about a carbon budget as if we exactly know how much we will have left until reaching 1.5 or 2 degrees Celsius. That's not the case. There are large unknown and uncertainties. We don't know how much the ocean will take up in terms of carbon dioxide in the future, or the vegetation or the land surface. And for this, we need to continue to develop the model so that we really can better simulate these feedbacks and get better ideas on how large the carbon budget really is. And certainly there are other developments, as for example, going to higher resolution to see what is then the effect on extreme events, how extreme will they really be. We see from the last years that we had quite maybe unexpected extremes, several all around the world in 2020, which we might not have expected, at least not in that size and strength. So models already now can provide a lot of input and information, but there's still a lot to do, I would say.
Franz, I wanted to ask you, what's your number one takeaway lesson from the pandemic for European climate policy?
I think one lesson is really that it's amazing that what has been said before, that people can change and policy can change amazingly quickly and react on a national level, but also on a European level. That does not solve the climate problem, but we have seen that there was a strong reaction from people, from policies to this pandemic, and I think that for me, that was also personally, I wouldn't have thought it's possible that from one day to another, everything stopped and the city was completely quiet. I mean, this is an amazing experience in a negative, but also in a positive. I see also the issues. There's a lot of issues with that, but I think it's also a positive aspect to see what is possible, what can change. And I think there's problematic things, as has been said, on people being locked at home, also people using more cars actually because they are worried to take the public transport. So on. It's not all positive, but there are some momentum that has been created towards more sustainable ways of living, also particularly in the cities, I think. And maybe we come back to the cities, that's where there's a good chance of reducing or improving life quality by reducing traffic, by reducing air pollution, by improving, for example, the possibilities to take a bike to go to work rather than the car and so on. We may come back to that later, but I think that's a positive aspect to take away.
And I think we are kind of coming to this, that one thing that you panelists seem to agree on is that we have seen like slightly unexpected flexibility from individuals and from the economy, that these lockdowns could happen, and we're still here. It was not the disaster that it could have been. And at the same time, like a lot of that flexibility has been, there has been a cost to it. There have been individuals who have taken up a lot of the care work, that is the kind of the traditional invisible labor, that will not be sustainably long-term sustained by those people, even though during a year or two it can be done. But John, I wanted to ask you now, like what lessons do you see that could be learned from the pandemic that should shape future economic policies, and both regionally or globally?
I would like to pass that question back to the natural scientists here in the room, because to me, one of the things that has, I think really formed my view on climate policy is the very large uncertainty about the climate sensitivity. And as I understand it from my from my natural science colleagues, is that a very important reason for that uncertainty is that we don't really know how to quantify short-run effects coming through, the effects of particles on aerosols, on cloud formation and things like that. And of course, one would like to make an experiment, close down emissions for some time and see what happens with these things, but we can't do that. But this was a natural experiment that we gave the Nobel Prize in Economics for this year, actually. So can I return the question, Hanna? Is that okay? Is it the
obviously
case that you who know these things, is it the case that that we will be able to narrow down the uncertainty about climate sensitivity from this natural experiment that the COVID was?
Astrid, do you want to go, or Franz, or Torben, or from the epidemics point of view, Joachim? I guess this goes to all of you.
I can probably go in terms of my main takeaways. I mean, one of the main takeaways is that the research community is extremely well linked and can keep up with communicating even without having to travel that much. I mean, there's certainly a need for meeting people and keeping in touch, but there was a lot of things possible and a lot of exchange about what and how to learn that I wouldn't have thought possible. And also, I think the extreme need of sharing data, making tools available in the community, and making sure that the knowledge is quickly communicated and available was emphasized in the pandemic. It was emphasized certainly when it comes to research on the COVID itself, but it was also becoming very obvious when it comes to assessing, for instance, the air quality and climate implications of the emission changes. And so I think that aspect and the need for even more elaborate ways of open science and open data concepts was something that is one of my key takeaways. And I think the latest IPCC report, chapter 7 there, did a great job in narrowing down the uncertainties when it comes to climate sensitivity. There's certainly still room for improvement. It's still the aerosols being the largest uncertainty, but they are not as large as they used to be before.
If I can comment as well, I think there's a lot to be learned from the experiment, the natural experiment, I think. And it's very important to learn from it, because it can really help policy work and people's understanding of both exposures like air pollution and their impact, which is not easy to actually understand, I think, in a sense, for people, what it actually means, because we're in our cities and we're exposed all the time. And unless we have a situation which documents a change, it's difficult to appreciate the impact it actually has on our daily life. And I think that could be generalized to a lot of situations. There's also other learning situations in terms of diseases from the changes of mobility and restrictions and hygiene and so on, which is also important, like flu. And we also made a study documenting a big change in dengue epidemics or dengue incidents due to the pandemic situations. I think there's a lot of to be learned from what we've seen, and it can also be important to bring that knowledge out to people, especially then in the ones that are relevant for the transformation of societies to more climate neutral states.
Franz Imler, I wanted to ask this kind of throw the same question to you. This natural experiment, do you see it narrowing down old uncertainties about the climate sensitivity enough that it would impact our ability to make better policies, and does it have a policy effect?
Well, I'm a natural scientist, but of course I'm not into doing this at the moment, but I've discussed actually this question with a number of projects doing climate modeling, whether this can help. I don't quite see this happening because climate is a very long-term thing. And change within half a year where something happened will not impact our climate projections for the next 30, 50, 100 years. It's always a bit frustrating to see this also from a policy point of view. Even if we do very strong climate policies in the short term, you will see the effect only in 30 years from now. That's one of the big challenges for the scientists, because you cannot verify a theory very quickly. You have to wait 30 years. But also in terms of policy making, because our policy cycle is of course a lot shorter, and that makes climate policy so difficult that you see the effect only on a really long term. So far beyond personal career in a policy or somewhere else. And that makes it so difficult. But from a pure science perspective, I don't think I don't think the COVID crisis helps narrowing down climate sensitivity. That's quite a wicked problem, actually. And there are improvements, as Astrid pointed out, that are based on various tricks, so to say, how to run it, these emergent constraints and so on, how to look at the climate models. At the same time, we see that some models with a higher resolution now have a higher climate sensitivity. So in some sense, you actually see the climate sensitivity uncertainty has increased recently again, because a new generation of models created again different. So it's really a wicked problem, and yeah, these predictions will stay uncertainty, and that's the other, again, back to policy, an aspect that needs to be taken into account. We navigate with high uncertainty. We don't know exactly what's going to happen. There will always be things happening that you have not foreseen, and there are tipping points in that system. We know that, but we don't know much about which ones are there and which one will be triggered when. So, and that creates a high degree of uncertainty that I don't think we will get rid of. We have to live with that uncertainty. And that's part of the problem of the climate crisis, that we don't know what's going to happen.
So that's similar to the problems that we have, that the short-run mechanisms are different from the long-run mechanisms. And for you, it's even worse, I guess, because what we mean with long-run is maybe a couple of decades, but with in natural science, it can be hundreds of thousands of years.
Astrid, you had a comment.
Yeah, I would like to just briefly emphasize that, of course, you are right for climate changes to be discernible in the data sets. You have to wait for decades. Actually, I think when you look back to when the first IPCC report was published, we did already wait for decades. So we do know what's happening, and we do know that even the first models were right, and there is no way of just in something like this being right by chance, and that's also why the Physics Nobel Prize was granted to climate modeling developments this year. And so I also think there is a number of things that we know for certain. So in terms of climate action and mitigating climate change, there isn't as many uncertainties as one might think. I mean, there is clear evidence that only when we manage to be carbon neutral by mid of the century is there the chance to really stay within or clearly below 2 degrees warming by the end of the century. And also, every 1/10 of a degree of further warming will increase the frequency and intensity of extreme events. And of course, it is not possible to forecast an extreme event in 10 years. We will not know if there is a flooding in June in 10 years and where exactly. But we know that our chances are increasing of having extreme events, and that they will be more intense even than they are now. And so in that regard, I would say there is a few certainties which are actually disturbing enough to act.
And before I start inviting questions from the audience, I had one more question to Joachim, and this is quite specific, but again, going back to the beginning of the pandemic, and there was a lot of speculation about the possible combination between COVID mortality and air quality. Were they linked? And do we know anything more now about how future pandemics will be impacted, or mortality in future pandemics? How are they affected by air quality?
We know much more about aerosol transmission, I think, overall, and in not only for coronaviruses, but also understanding on other diseases, viral diseases like the flu. And I think we also understand a little bit better why those diseases are partly seasonal. And it might also link up with air pollution exposures to some extent. But there's a lot of behavioral components in that as well. So it's continuously going to be difficult to know what is what and so on. Yeah, so we know much more, and that's good. But I don't know if we could make use of it at the moment in preparing for the next pandemic. I think what's much more important in terms of preparing for the next pandemic is actually how we interact with wildlife and domestic animals, and how these zoonotic spillover events are shaped. I think we will see much more research, but also in prevention, where one could actually link up the climate environmental crisis to the pandemic crisis, because it, in a sense, it shares at least not everything, but part of the root of the problem would be a little bit the same. For example, food consumption and meat consumption and wild meat consumption, and also deforestation and such changes. I think that might actually be the more important part of the sort of the health pandemic climate linkage, where a lot of opportunities would be given to mitigate both problems at the same time.
Yeah, yes, and so maybe in the future it will be easier to convince policymakers that, for example, land use questions are not, while they're climate issues, but they're also public health issues.
Yeah, absolutely. And there is so much focus on those at the moment. I expect we'll have a lot of more research and knowledge in a few years, which is very good. But we obviously also need it right now, but better soon than never.
Thank you, Joachim. And now I would want to invite one more person to the conversations. We have Pelle Boberg from Sweden's Environmental Protection Agency online. We'll not see Pelle's face, but we can hear his voice. So Pelle, what is your takeaway from the COVID crisis? What lessons for climate and air quality policies do you think we can draw on for now, and how to move forward after COVID-19?
Yeah, yes, thank you. And thank you to all the panelists. It's been very interesting. I don't think that we have a complete analysis of this from our agency. But I would like to mention, I don't know if it has been mentioned already, but the Swedish Climate Policy Council had this theme on their latest report this spring on how the Swedish recovery policy has worked out for climate, focusing on climate more than air quality. And I think there are some interesting things there. And I also believe that the Policy Council is continuing looking on this also ahead of their next report. This is a yearly report, so it will be presented early next year. I think, if I'm not mistaken, one of the parts of what was put forward in this report this spring was, for instance, as an example, that how the aviation sector had quite a large support during the recovery that has not been very marked by environmental commitments. So this could maybe be one example, one takeaway of how the continued recovery can be more aligned with the green objectives.
Yeah. Thank you, Pelle. And now I want to see if Miles Perry is online. I also wanted to.
Can I give a short comment?
Yes, please do. Yeah.
Yeah. So what the Policy Council, the Swedish Climate Policy Council, looked at was consequences for Swedish territorial emissions, and And since Pelle, since you took up flying, flying within the European Union is within the EU ETS. So whatever Sweden did with, saving SIS or something else, it doesn't have any impact on emissions from aviation within the union. So if we manage to to shut down some flying in Sweden, it would just leave more flying outside of Sweden in the union. So I think that's an important takeaway that I think the Policy Council missed, because they are not evaluating overall emissions outside of Swedish territories.
And then I'd like to ask Klaus Weiser to ask the next. He has a question to John Hassler. So you, John, stay tuned. This is for you. Hello, Klaus. Now we can hear. I think we can hear you. So if you could just go on and pose your question. Okay, since we're not hearing Klaus, I'm going to, because I have his question in writing here. So all the studies presented here agree that that the last year's emissions reductions have no impact on the global climate. There's no warming, no change in the warming trajectory. He says that Foster et al. And COVID MIP present green recovery scenarios that assume that some of the investments for rebuilding the economy would be rerouted from fossil fuel-based technologies to new, greener technology. But is there still a chance for such a scenario to happen? Or is it too late because of the decisions about economic recovery that have already been made? John, did you hear that?
Yeah, of course it's not too late. I mean, it depends on what you mean by that. I mean, if you think that it was kind of a golden opportunity to close down airlines, and you think that that's going to be important for the climate, then that opportunity is perhaps missed. But I don't think that's not going to be important. And when it comes to kind of, for example, what Biden's plan is going to be used for, that's not too late, of course. I think that, without a clear commitment in terms of, for example, an emission trading system in the US, it's not going to have much impact in itself. But maybe it's going to pave the way for such a system, and then certainly it's not too late for that.
Then we have the next question is, let me see that. Ilona, do you want to pose your question to Joachim, or do you think that this was already covered?
Yeah, I think much of it was already covered. I didn't manage to post the Q&A session, but maybe I can kind of reformulate it a bit. So there's been a lot of discussion about the need for like strategic climate policies. And then on the other hand, you have said that, okay, the pandemic clearly was not any golden opportunity to somehow jump on like a better climate trajectory. But instead, it may have been a golden opportunity for us to demonstrate our ability to make behavioral changes. So then my question to Joachim is, I think you already kind of alluded upon this, that there are examples from the public health of making policy interventions and inducing behavioral changes. So from your perspective and your experience, what are the lessons that we could learn from the public health interventions to facilitate faster climate action? Again, I'm asking for a very quick policy pitch. Like, what do you think? What are the key points that we should take?
It's a big question, but no, I think, yeah, we have learned a lot, and there has been public health interventions that's been through the behavior, and Astrid was bringing up policy and tobacco control as one of them. But the whole public health field has a tradition on actually working on changing behavior. It's very important for chronic disease, for cardiovascular disease and cancers and so on. And in terms of climate and the diseases and in our relationship to climate and our emissions in behavior and how we actually understand and also understand the impacts from climate on our lives and our health is very important, I think, to motivate our behavior change. So I think we need more knowledge on the nexus between climate and health overall to convince people to have the arguments and the motivation, something that's not temperature, it's actually health. It's our health or it's our children's health. Very important arguments. It's always difficult, as Franz said, to work on something that's in the future, but the closer you get to humans and to people's lives and health, I think it will become a little bit easier, although it's still going to be a long journey actually to actually affect it. But yeah, so not so short answer. Sorry.
Now we have or did someone else want to comment on this? If not, then I would ask H.C. Hansson to pose a question to John, if they're present and willing to ask. And if not, I can do the same thing as before. For the individual, there needs to be alternatives to be able to make a choice. What can the government do to facilitate such alternatives? And is that also solved by decreasing CO2 shares? John, we can't hear you for some reason. You seem to be unmuted, but we can only hear some static. Well, let's do this. Let's move on to the next question, and Matt can figure out if there's something on our side that needs fixing, or if it's something that John's microphone or something is having.
If I try another.
Yes.
Microphone?
No.
Okay, something wrong with my regular microphone. So what an emission trading system does is to kind of put limits on how much emissions can be allowed in the system, right? Then, of course, for the economy or for households and firms to be able to live and have good lives and make profits and so on within the system, lots of things is important. And also government intervention is important there. So for example, if the emission trading system is introduced for transport services, we'll have to go over to electric cars or at least non-fossil fuel cars. And for that, to be smooth, government intervention might be required here and there. It could be, that local governments allow charging poles and things like that. So lots of these things must happen too, for sure. But in a sense, I think that kind of the key is to put these aggregate limits on emissions, and then, as I said, lots of stuff is gonna have to happen where the government is not unimportant, for sure. And that I think that's maybe what you are aiming for, that the government, is important in helping to make sure that there are alternatives. So for example, electric cars, but electric cars are not going to be produced by the government, but it's not that the government is completely unimportant in that transition.
Thank you. And then next I'm going to call on Stella Papadopoulos if she is online. Okay, apparently if not, then Annika, you can ask your question.
Hi, yes, I had the same problem as Elon. I can't post my question in the Q&A, but it's been a really interesting discussion, and I guess my question, it's along the lines of what has already been discussed, but I was wondering a bit if the pandemic in any way has helped making policymakers and people more in general also aware of the negative impacts of climate change, not only on maybe health and so on, but also on the economy, that it's not that we're indestructible, but things can go very wrong if we don't do anything about climate change. Has that sort of been, are people more aware of this now, or has it not changed at all? I don't know
who wants to go first.
Who can answer, but it's maybe we need a social scientist here, but yeah.
Exactly. I don't think we have the scientific expertise. We probably only have opinions. I don't think so I do think that awareness did increase in the last couple of years. I don't think it was related to the pandemic. It was related to extreme events. It was related to say the youth being more active in terms of making clear they won't tolerate inaction forever. But I don't think that the pandemic in itself did a big aspect there.
So next up, I've been told that Stella Papadopoulos is online now, so please go ahead and pose your question. No, unfortunately, we're not hearing you. So it appears that we have a systemic problem. Okay, so I will briefly address your questions. Okay, so far we've been talking about COVID recovery plans and then emissions reduction plans as two separate initiatives. And Stella wanted to ask about how, like, the spaces where those two emissions reduction plans and COVID recovery, where can they interject? And of course, like we've talked about the boom in remote working, but could there be more points where we could, and maybe even adding not just like COVID recovery, emissions reductions, and then these more general like lifestyle changes or like changing practices in work life and so on, where are the places where these could be pushing each other to the same direction? Is it again a moment of needing a social scientist, or Franz, do
maybe I can say something, because I mentioned earlier, I do think there's a correlation which is based on this coincidence, basically, that both things happen in a similar time frame. And a lot of these recovery packages at least have written that they should contribute also to climate objectives. As I said, Next Generation EU, 30% of the money should go to climate-related investments. And I think that can play quite a big role. I think there's a good opportunity that a lot of this investments that are happening now at a large scale, also in US and other places, are being directed in a more climate-friendly economy. I would also like, maybe in this context, mention that I mentioned already cities a while ago, and I think there's a good opportunity because, and there's the link also with the health issue, that a lot of people realize that, you know, a less traffic polluted city, noise polluted city is an advantage. And we are starting currently an initiative called EU Missions. There's also a mission on cities, on climate neutral cities, and there's a lot of interest and response to this. A lot of cities are now, and you can see that probably in Brussels you see it, but in Paris very strongly, they now really change the way they want to manage the city in terms of also manage the traffic, less for cars, more for public transport, for bicycles. And I do think there's a good link where these investments are directed in a more climate friendly direction.
Thank you. And then this might be our last question. Let's see, unless someone wanted to answer that last Stella's question still. Or then I'll invite Eric to ask your question, please.
Yeah, thank you very much. And my question is maybe a little bit similar to some of the last questions, but when putting together the presentation today with all of these nice graphs, it's very striking again how strong the links and I mean potential co-benefits are both for air quality, health issues, and then climate, and trying to mitigate both problems at the same time. Still, I think that we very often talk about climate and climate change mitigation, and there is a lot of talk, and I'm not totally into that community, but there is also talk, of course, about air quality issues and that part. So my question here is a little bit if you also have that kind of general perception, and if you think it would be somehow improved if we talked more about this in a collective way, talking about both problems at the same time, and if that in that case could have any potential impacts on the way forward, and as I wrote in here somewhere, I mean, to get things done a little bit more. So it's a general question to basically all of you, and I think maybe you have touched upon it, some of you already, but I think it would be nice to hear a little bit more about that. Thanks.
I could start maybe. I think it's really important actually to bring it together and look at it because it's one system. And it's going to happen at the same time, and it's going to be affected by the same policies. It's really important to bring it together and to work more interdisciplinary to address these issues, interconnected. And as I think back to Franz' situation, these cities, the forerunning cities of change, where there's taking this bold vision to go climate neutral, going to have a lot of important evidence as well along the way to convey this message on the benefits, and the big benefits and the people care about is going to be short term, I think. So it's important to have these air pollutions, for example, impacts directly. It's the benefit you get almost immediately. And at the same time, you get this long-term, climate impact. So it's also a little bit of a time sensitivity in getting your benefit, which is important, I think, in this situation.
I think an important aspect there is that a lot of the So in the IPCC Chapter 6, there is also the FAQ about how do air quality and climate actions play together, where's win-wins and where's not. But I think one aspect that is really important to emphasize is that as we do move towards a non-CO2 defossilized future, we have to make sure that the sources of particulate matter, so at the moment the communication is very much into, or what people understand is very much into, well, you avoid particulate matter, you do something bad for climate. I think when we move towards CO2 neutral and defossilized futures, this is no longer an option. We are no longer going to drive a diesel car with a particulate filter. That's not what the measure is going to be. It's going to take out the whole bunch of emissions. And I think we have to make clear that this benefits then both climate and health. And taking that perspective and making clear that as you move away from kind of the impulse to burn something just for having energy, that will really benefit health and the climate. And I think this message has to come across.
That's very good, Astrid. And then John, this will be the closing of our panel. So please, John, go ahead.
Well, so then I'll say that, in order to deal with climate change, we need to convince China to phase out coal and make sure that India don't follow the same fossil intensive growth strategy. And there I think Erik is right, that one of the things that make me hopeful there is the fact that air quality is an enormous problem in India and China that ordinary people really care about. So it is kind of a strong political pressure on that. And perhaps actually the fact that air quality was temporarily much better during the COVID crisis is going to strengthen that pressure, and that then makes me more optimistic.
Thank you, John. And for my part, now I declare this panel closed. Thank you very, very much, all of our participants. This has been fantastic. And on to you, Ilona and Annika.
Yeah, so I would also like to express my thanks to the panel members. Really, this has been a delight to follow your wise words and listen to this discussion. Thank you for donating your time to us. And thank you, Hanna, for doing such an excellent job in asking insightful questions. So it has really been a high quality discussion, I feel. And we have gotten a lot of food for thought, I feel, for finalizing the policy brief. And now we will work on these impressions that we have gotten from this conversation and put together the final version of the brief. And all of you who have been registered for this event, including all the panelists, you will receive the brief. You're also welcome to send us any inputs or any comments that might occur to you later on. We are now 3 minutes before 4 p.m. So we are also excellently on time. So I think I will just take the opportunity also now to thank Erik and Helena, who have and will be working on this policy brief in the future. And we are really looking forward to finalizing the process and interacting with you also in the future, those of you who are in the audience and in the panel. And if you're curious about FORCeS as a project and the research that we do on atmosphere, air quality and climate, please go ahead and visit our website or be in touch with us. I hope I didn't forget anything important. Now is the last moment to point it out if I did. Otherwise, I will just like to wish you all a nice Monday evening and close this session for today. Thank you very much.